Another set operation we can do is the Cartesian product. But before we talk about that, let's talk about ordered pairs and ordered tuples. So if we have an ordered pair, it has two elements and they're in parentheses. And this is a pair of elements and the order matters. So if we have this ordered pair and this ordered pair, they're different. So these are not equivalent because order matters. You can also have groups of three that order matters. This is called an ordered triple or triplet. So the order there matters. So this one is different than this one. So they're both ordered triples, but they're different ones. They're not equivalent. And then once you get more than three, then we start talking about them as tuples. So we can have a four tuple, and that's a group of four elements that where order matters. Okay, so there's a four tuple, and you can have a five tuple, and you can have, and then you start talking about n tuple, and n is just simply specifies the number of elements. So here's a five tuple. All right. So now, how are these different than sets? They use parentheses. They still separate with commas, but now order matters. So things in different orders matter. Also, duplicates matter. So we might have an ordered pair that is this, and that's really it's a pair. There are two of them, and or there's three of them, right? And order matters, and the number of them matter, because this is a pair, this is a triple. And so they're different. They're not equivalent. So that's how these are different than a set. So now that we understand how this works, we can talk about a Cartesian product, because Cartesian products produce these kinds of ordered pairs or ordered triplets or n-tuples. So the Cartesian product produces a set. So let's get a couple of sets here. The result, it works on sets and it produces a set. All right, so here we have set A, which has the elements 2 and 6. And here we have set B, which has elements 1, 6, and 5. All right, so there we have two sets. So now if we want the Cartesian product, which is 8 times B, that's the Cartesian product, it is a set of all the pairs, right? And these are ordered pairs because A comes first, then the first element in each pair comes from A. So in this case, it could be 2, followed by an element of B. And the Cartesian product is every combination of A and B where A, the ordered pair, the first element in the ordered pair comes from A, and the second element in the ordered pair comes from B. So it's all the combinations of these. So we could have 2, 1, 2, 6, and 2, 5. And then 6, 1. Now 6, 6, and 6, 5. All right, and that is all the ordered pairs. So here it is a set of ordered pairs where the first element in the pair comes from A and the second element from the pair comes from B. And you put all the combinations. And that's the Cartesian product. Now, if we do B times A, notice how this is going to be different, right? Because now the first element needs to come from B. So every element in the ordered product needs to come from B. So there'd be 1, 2, and the second element in the ordered product will come from A. So this will be 1, 6. And then we'll move to the next one, which is 6, 2, and 6, 6, and 5, 2. Oops, that's not a 2, that's a 5. 5, 2, and 5, 6. All right, now notice how these are different. Now it doesn't matter what order these are in, like I could put this ordered pair here because this is a set, right? And sets order doesn't matter, but it absolutely matters what order the pairs are in. So that part is ordered, but where they come in the set, because sets are not ordered, doesn't matter. Now notice that when we do A Cartesian product B, or B Cartesian product A, they're different. The ordered pairs are different. But notice how they have the same number of elements, right? When we do the Cartesian product of these two, in both cases we come up with 6 different elements in the result set. So let's talk about the cardinality. So the cardinality of A cross B is equal to the cardinality of A times the cardinality of B. So let's look at that. So the cardinality of A is 2. So let's just fill them in. So we can count the cardinality of A cross B, right? There's 1, 2, 3, 4, 5, 6 distinct elements. So the cardinality A cross B is equal to 6. The cardinality of A is 2 distinct elements times the cardinality of B, and the cardinality of B is 3 because there's 3 distinct elements. And sure enough, 6 equals 2 times 3. So you can see how these get really big, right? The Cartesian product. So if you have a set with 5 elements and a set with 8 elements, the Cartesian product will have 40 elements. If you have a set with 10 elements and a set with 12 elements, the Cartesian product will have 120 elements. And you can tell how many it's going to have by multiplying the how many distinct elements are in A times how many distinct elements are in B.